Flattening a 3D globe onto a 2D surface is like peeling an orange. It can't be done without tearing, stretching, or compressing. And as a result, every map projection introduces distortions into one or more of four geographic properties: shape, area or size, distance, and direction. So let's talk about some of the most common map projections and how they distort the map, and then what each map is used for. Okay, the Mercator projection is one of the most common projections. It's a cylindrical map that projects the Earth onto a cylinder. It preserves direction and local shape, but it introduces extreme area distortion at high latitudes, like how close you are to the poles at the top and bottom of the Earth. Now, land masses near the poles appear massively enlarged in this projection. For example, Greenland looks like it's the same size as Africa, but Africa is actually 14 times larger than Greenland. This map projection is commonly used in marine and aeronautical navigation, and it's what most standard web mapping tools like Google Maps use. Now, the Gall-Peters projection is a cylindrical equal area projection that prioritizes the true proportions of Earth's land masses. It preserves the area. So every landmass actual surface area is accurately represented relative to the others, but it really distorts the shape. Continents appear severely stretched, elongated, and distorted, especially near the equator and the poles, making regions look really unnatural. So this projection is often used for things like thematic maps focused on global population density, resource distribution, and world maps designed to emphasize the true size of different nations. Now, the Robinson projection is a compromise projection that attempts to create like a visually pleasing, globally balanced map by sacrificing a small amount of accuracy in all the categories. So nothing is perfectly accurate, but nothing is severely distorted either. It's used mainly in general purpose world maps and textbooks and educational settings. Now, the Winkel-Tripel projection minimizes the combined distortion of area, direction, and distance. It preserves a balance of size and shape across the entire globe, and it's widely considered one of the most accurate looking representations of the spherical Earth on a flat plane. It has slight distortions at the far edges and the poles, but avoids extreme stretching. This projection was actually adopted by the National Geographic Society as the standard projection for their global maps. Finally, the polar azimuthal or equidistance projection is a planar projection that centers on a specific point on the globe, usually the North or South Pole. This projection preserves distance and direction from that center point, but the area and shape stretch and become highly distorted as you move away from that center point towards the equator. This one is used primarily for airline flight planning over the poles. So remember, flattening a 3D globe, like the Earth, onto a 2D flat map always requires a compromise and causes various amounts of distortion to the shape, area, distance, and direction on the map. So different projections have different uses, and each projection tells a different story.